All right, everybody, so now we're going to be talking about finding the area of regular polygons today. Now, you're going to need a couple of definitions, and I've put one in there. And I want you to go ahead and pause the video and take these down. All right, now, the central angle of a polygon, right here, that's going to be this angle right here, angle QSR. That is your central angle. If you want to label it so you have it as well. It's made by two different radiuses, or radii. That's the appropriate way of making it plural. And so we've got our radius right here. It could also be QS, whichever one you want to label, but these right here, that's your radius. So SR or QS. Next, you've got the apothem. Now, the apothem is something different. That goes from the center all the way to the side. So we're going to say that that's our apothem right there. And it's side ST. Don't forget that your center is just point S. All right, now we're actually going to go ahead and apply all of this. So, the area of a regular polygon is found by this following formula. Now, I want you to remember that A, right here, that's your apothem. And then P right there, that's going to be your perimeter of the polygon. Now, another way to write this is A is equal to 1/2 times A times N times S. And I'm putting those just so we can write each of these out. What it is that N is the number of sides, and S is the length of the sides. It's the side length, which N times S, that is our perimeter anyways. When you're adding all of them up and it's a regular polygon, they're all equilateral and equiangular. So let's find the angle measures of this regular pentagon first, and then we're going to find the area of the different polygons that we have been given. All right, so we've got a regular pentagon, which means our central angle, as it said in our definition, is going to be 360 divided by 5. It's divided by the number of sides. When you do 360 divided by 5, you get 72, which means that's how much angle 1 is going to be. Using angle 1, you can also figure out this one, which would be congruent with angle 3. Or you can notice that angle 2 right here. Angle 2 and this adjacent angle, those are both congruent. They've been bisected by our apothem, which means we can just do 72 divided by 2, and that gets us 36 degrees. Now, you can find the angle of 3 just by finding a triangle, because we know that this is 36, so we can figure out what that is. Or you can do 180 minus our central angle and then divide whatever you get by 2. Either way, no matter which way you choose, you should end up getting 54 degrees. Sometimes you're going to have to use sine, cosine, theta of theta and tangent of theta to go ahead and figure out your apothem or your side length. And the examples I've given you, you won't have to do that for this side. Now, let's write out our formula. Remember, it's 1/2 times A times P. P being our perimeter. We know that our A value, our apothem, is right here, and that's going to be 8 inches. Our perimeter is this entire thing right here. But each of these have the same exact measurements on this octagon, which means to find the perimeter, I can just do 8 times 6.6, or the n times s. When you plug that in, you should get about 52.8 inches. And then all we're going to do is drop it in. So it's 1/2 times 8 times 52.8. If you're trying to do it in the calculator, sure, you can use 0.5 for 1/2, or you can do 8 times 52.8 and then divide all of that by 2. Once you've plugged it in, you should get that your area is 211.2 inches squared. And it's really that easy when you've been given everything. All right, so now I'm going to have you do number 3, and I want you to check your answer with mine. You have to submit this and show your work for it. You should get this answer right here. Remember, if you ever need to just type it out, you can also just write square centimeters. If I want you to do anything different, I will give you those instructions. All right. Now let's go ahead. We haven't been given a picture. We've just been given the description. So that's fine. We can still do it. And it's times like these that, I don't want to think about this formula. I think about it as A times N times S. It's the number of sides times the side length. Well, I know that my apothem is 33.6. And then the number of sides I know is going to be 12 since it's a dodecagon. Multiply it by the side length, which is 18, and half all of that. And when you type that into your calculator, you should get 3628.8 feet squared, or again, square feet. And it's really just that easy. You're just dropping it into a formula. So I want you guys to do number 5, and I'm going to give you the answer for number 5, and you have to show your work for it. All right, so make sure you show your work because you're going to have to submit this one. All right, now let's go to the back. Sometimes you're only going to be given one side length. So you're going to have to use special right triangles to find the area. When that's the case, I want you to write your answer as either an integer or simplified radical, whichever one is more simplified. Don't forget all the 2's on the hypotenuse. So you've got your 2's and your 2's right here. You're going to have to think about your angles right here. So we're going to do number 6 first. Number 6, we're working with a square because it's a regular polygon. So we know that it's going to be equilateral and equiangular, sorry. So this is 8 right here. And it's splitting that 90-degree angle in half, which means this is 45 degrees. That means this will also be 45 degrees. And so now we're working with a 45, 90. I know mine's not drawn to scale, but still. When you have something like this, remember, label it up. All the 2's on the hypotenuse. And then solve for x. So 8 squared x square root of 2 is equal to 8. Divide both sides by the square root of 2. You get x is equal to 8 over the square root of 2. You're going to multiply the numerators and the denominators by the square root of 2. You're going to get 8 square root of 2 over 2. That simplifies to 4 square roots of 2. That means your apothem right here is 4 square roots of 2. And half of this side is 4 square roots of 2. That means this entire side is going to be double that, which is 8 square roots of 2. Now, all you do is plug it into your equation. 1/2 times my apothem times the number of sides times my side length. We want to keep it as an exact answer, so we're just going to work with the integers outside. And the way I'm going to do is I'm going to do 4 times 4 times 8 times the square root of 2 times 2. Outside times outside and inside times inside. And I'm going to put it all over 2 since I'm dividing it by 2. That just makes my life easy for me. And then what I'm going to do is I'm going to have to end up simplifying this. So 2 times 2 gets me 4. And that's 4 times 8. And the square root of 4 is, well, it's just 2 all over 2. These are going to 1 out. You get 4 times 8. And you should get 128 meters squared as your answer when you plug that in. Now, because this was an integer, you ended up getting an exact answer anyways if you type it into your calculator, so you should be fine. But sometimes you're going to have problems like number 7. Now, in number 7, you've got an equilateral triangle. So that means these are each 60 degrees. All right. Okay. Well, we know then if we get a radius right here, that's going to split that angle. I'm going to get a 30 here. And this is going to be a 60. So let's draw our 30, 60, 90. Okay, and we've been given this length. I want you to label that special right triangle. All the 2's on the hypotenuse. This is the shortest side here. And then this becomes x square root of 3 because you have 3 different angles. Well, this one's going to be pretty easy to figure out. We know that this side length is going to be 4 square roots of 3. And this radius is going to be 2 times 4. That's going to get me 8. But you know what? I don't really care about that radius. All I need is the apothem and the perimeter. And the side length is going to help me find that perimeter, which means I'm going to get 8 square roots of 3. Well, let's go ahead and plug it in. I get A is equal to 1/2 times my apothem of 4 times the number of sides times my actual side length, which is 8 square roots of 3. I'm going to multiply all of my integers. 4 times 3 times 8 all over 2. Multiply it by that square root of 3. Okay, because it's outside times outside and inside times inside. So You get 4 times 3 times 8. You're going to divide that number by 2, so it's 96 over 2 square root of 3, which means what that is really is that it's 48 square roots of 3 centimeters squared. All right, so I want you to try number 8. I am going to help you set it up. And I want you to remember that you've got 1, 2, 3, 4, 5, 6 sides. So that means your central angle here is 60. That means each of these are equilateral. And when you split it and you find this apothem here, you're going to be using a 30, 60, 90. And what they've given you is the hypotenuse of it. So don't forget all the 2's on the hypotenuse. You've got this and x squared root of 3. All right. So I want you to go ahead and submit your work for this. And you should get an apothem with the radical. And your final area will be 150 square roots of 3 meters squared. Make sure you submit your work for this, okay? Thanks.